So, right, let's get going. Title of the talk, obviously, Consolidating Services with Middleware. And what I'm going to argue here is that if you're doing sort of HTTP-based microservices, then really middleware is your friend, and you're gonna want to use that, and you're gonna want to understand what that is. So we're going to talk about that. My name is Christian, as it says up there. I'm freelance, so I get to sort of go different places and see people's different systems. And we're going to sort of start out talking about some examples drawn from different client systems. So it's not exactly taking from one exact system, but it's kind of stuff that is pretty close to what I've seen, and I'm going to talk about how in those situations we've used middleware to make things easier, really, and make things nicer. So it's not drawn from one project only, but experience-based still. Right. So, yeah, I'm going to talk a lot about middleware, and well, why really? Well, middleware gives us some different stuff. It's really flexible, so it's a quite flexible way to sort of get some building blocks that you can put in the order that you want, and you can reuse sort of across different situations and sort of, well, you use in different ways. It's nicely componentized, so you can really get into a situation where you have like just one little thing that does that well, and then one other little thing that does that well, and you just have these nice little components. As I said, they can be quite reusable, especially in sort of a microservice setting, which we're going to talk more about. Lastly, they're quite testable, at least to the point where sort of it's kind of your own fault if they're not that testable. So from the outset, you can they're small and easy to sort of spin up in a test environment, and you can just have them there, which is also really nice. So these are some really nice sides of middleware, and lots of the reason why I like middleware. So I promised you sort of some stuff from the real world, based on real systems I've worked on. So first of all, these the things here are sort of microservice systems, and well, hooray, we're all doing microservices today, because that's seems to be the thing that we do, right? Have to do that. So everybody does it. Well, maybe there's more reason than that, isn't there? So just sort of to touch a little bit on that. Why do microservices, and sort of why do it in the systems, at least, that these examples are based on? Well, sort of microservices, I like to say that they sort of enable continuous delivery, but it's sort of a two-way street, I'd say. Sort of with microservices, you have lots of small things which just is unmanageable if you can't really automate things, and you can't do continuous delivery really. And then on the other hand, setting up all the automation needed to do continuous delivery gets easier if the things you're trying to deploy are smaller. So it's like there's sort of a yin-yang thing going on there. One makes the other one easier to do, and on the other hand, sort of one needs the other one to even be good. So those go hand in hand. You can get highly maintainable services with microservices. Again, it's just really the fact that they're kind of small. So they're small enough that you can fit them in your head, and you can actually sort of reason about them, think about them, and know what they're doing. So that's a nice point as well. And quite closely related to that is that you can get a really efficient sort of developer workflow. Compiling is fast, spinning them up is fast, the deployment can be fast, and so on and so forth. So you can get the feedback, and you can get into a good rhythm with it. You're not in the situation where you sort of open up Visual Studio in the morning and then go have a coffee, and half an hour later Visual Studio and ReSharper and everything is sort of loaded because you have 7,000 projects in your solution. It's just like a couple of projects in there, and it's fine. Yeah, I wrote this robust by design. So microservices can be robust by design. As with anything else, you can shoot yourself in the foot quite easily, but you can make sort of communication between the different services quite explicit and quite sort of in your face, and you can put sort of robustness around that communication and how that works. And if you're sort of good at designing how those collaborations go about, then you can really design some highly robust systems, and that's really nice as well. And lastly, again, things are sort of cut into smaller bits and pieces, so you can get some flexibility around the scalability. So you don't have to sort of scale the whole system to the same level. You can sort of find the bottleneck and scale that out instead of scaling every single little bit of it out. So these are sort of, I guess, more or less things that people will often highlight about microservices, and these has definitely been reasons why we've chosen microservices in some of the systems I've been involved with. That we sort of wanted these kinds of things. We wanted the system to be easy to work with, robust, and be able to deliver quickly, and so on. So that's sort of why even do it. And then sort of through the talk, we're going to talk about, well, it comes at a price, and middleware can help us sort of pay that price. Again, let's put some examples in here. So this is again based on a real system, a system where well, it's not so important. It's important what that one says really. The middle one there is the important one. It's a system where sort of end users can get notifications about stuff. In this case, what I've drawn here is, so imagine it's some kind of an e-commerce site. You can come up with like special offers for this or the other, like buy 3, get 1 free, stuff like that. And then you want to sort of notify users about that. And in the system that this is sort of loosely modeled on, we did it more or less like this. So we sort of have these special offers up here, and so this guy here is supposed to be sort of in something publishing events. So it's sort of like, okay, I create a special offer, and that gets evented out to the world, and whoever wants to sort of react to that can. And in this case, there's sort of this loyalty program thing that wants to react to this and say, oh, I have some customers registered in my database, and they have different interests and so on. If the special offer matches that, then I want to notify them. Then I have a service for that. I have a notification microservice for that. And that one doesn't actually do the notification. It sort of just knows about users and knows about, again, sort of their preferences, and some want an email, and some want an SMS, and some want a push notification. And then we have sort of other microservices out here sort of handling the integration towards whatever systems are needed to send the SMS through a gateway or whatever you need there. So so this is quite fine-grained. But with the system that this example is modeled on, we really got, I would say, at least most of the points or the bullets on the previous slide. Each of these were quite small, easy to work with, efficient workflow. We were able to do continuous delivery with these because they are quite small, and if there was like a bug with the integration to the SMS gateway, it was just this guy that needed to be redeployed, and not all of the rest of it, and it was quite nice. Now, sort of you have sort of direct calls some of these places, but the thing triggering all of it was this event-based mechanism, and sort of by design, there's some robustness up there, because the events are stuff that have happened, and it's okay to look at them again, and sort of if it fails, we can just try a little bit later. It's a background thing. It's okay that you get the push notification half an hour later if there's a problem, or half a minute later, or whatever like that. So this actually worked quite well in that setup. Now, all the communication here was HTTP. So the events up here, that's like an RSS feed, basically. So the initiative is down here, and that guy sort of asked, do you have any new events for me? The last event I saw was number 100. Do you have any above that sequence number? I said, no, I don't. Okay, wait a while, and then, do you have any now? Oh yeah, I have 10 new ones for you. Fine, we'll do that. And then you can sort of just go through. And then the rest of them, they're sort of pretty standard. Just HTTP calls, do this, do this, do this. So there's quite a lot of HTTP communication going on here. Another example, sort of taking from the same system. So it's a system where, so imagine a system where people can, a classified site, and that classified ads can come from different places. One of them is so what was called a dealer application in this case. So sort of companies that wanted to list things in these classified. Now like private people, just normal people could do it also. So there are different channels that could do this. Same kind of thing. The dealer went into the app, created this the listing to go on to the site, and that resulted in an event that comes out of a feed. Now that could also come from sort of other sites out there, sort of other partners that wasn't directly built from here. Same kind of mechanism with the event feed. That goes into sort of a common store with all the listings. Again, and that sort of has events as well. Oh, there's a new listing. There's a new listing, and then there's there's a search index that gets updated based on that, and then there's a site that actually uses the search index. So you can go to the front page of it and sort of search for blue cars, and then you get the blue cars sold by dealerships or sold through some other site, whatever. And as it turned out, there were actually sort of several different classified sites. Some were sort of for selling everything under the sun, and some were sort of for selling specific verticals and specific things. And they shared the same data. So you had sort of and as it is with slides and architecture on slide, right? It's simplified compared to the real world. But I do think that you sort of get the picture that, again, this is all HTTP, and there's quite a lot of HTTP communication going on. And you could sort of say, why do all this over HTTP? Why isn't it queues? Why isn't it something else? Pick your favorite. And in these cases, it was really very much a matter of the fact that HTTP is there, right? And HTTP works. We know how HTTP works. We're sort of quite good at monitoring stuff on HTTP, and sort of any stack can talk HTTP. It's quite ubiquitous, so it's sort of it's a good place to sort of just go and at least start there. And to be honest, coming into the systems that this is based on, I sort of had the reaction of, HTTP, that sounds very sort of synchronous, and it's going to not be very robust. That wasn't the case, I'd say, after a while, and specifically because you can sort of design how the communication works, and you can think about who sort of has the initiative. And in this sort of case here, like these lines, this guy up here is just sort of stores that there's a new listing now. It's fine. And then the initiative is down here. He says, okay, I need to find the new listings. And so he's responsible for retrying after a while. It doesn't have to be a fast retry. This is eventually consistent. It doesn't have to be like milliseconds later. So just sort of a background task. Wake up, ask for new events. Sleep. Wake up, ask for new events. That's actually quite robust and quite simple. It's really not that complicated to do. So turns out actually quite nice to work with HTTP for these things. Now, does that mean you should use HTTP for everything? Oh, I don't think so, but it can be a good option. Right. So, sort of along with microservices comes a few things. And now we're sort of getting into the cost of doing microservices. It was all like, oh, these small things, and they're nice to work with, and it's all been good this far. There are things that you need to master and able to be successful with microservices. You sort of need to be this tall. So you need to have like a good relationship, at least, between sort of dev and ops. I think people have been talking quite a bit about this for a few years, but it still holds true that having all these small things, getting them up and running, being able to update each and every one of them sort of quickly and not sort of in a big orchestrated way, but just one thing here, it's just not going to work if it's I've developed my thing and now I throw it over the wall and see what happens. Sort of have to be working together. Okay, it's pretty basic. Then you also need to be quite good at sort of logging and monitoring. And that sounds really basic, but I think a lot of systems are good at this, but there are also a lot of systems that aren't really good at this. But it's really necessary in these situations to have some insights to how the system is doing. You have all these small moving parts. You just can't afford to do something ad hoc for each of every of these services. So you have to sort of know, how do I monitor a service? How do I know if it's up? You can't sort of just kind of test each of them a little bit here and there, because you'll have, if you follow these microservice principles, you'll have hundreds of microservices. It's just going to be too difficult. So sort of some standardized, uniform logging and monitoring across these services is invaluable to have. And that's actually some of what we're going to focus on today. And then sort of moving up, you need to be quite good at automated tests and automated builds. So you have to sort of have that set up. You run your tests, you run your builds, and you can see if it's successful or not. So that's the CI, continuous integration part. And then sort of on top of that, you probably also need some automated deployments, and along with that, sort of fast provisioning of things. Because if you do something like this, and if you do something like this, not only do you have many services, but you will also find that you need to create new ones on a regular basis. Maybe not a daily basis, sort of depends on your scale, but on a regular basis, quite often. You'll find that, I don't know, in this vertical down here, there was sort of a specialized store and then the search index. And the first approximation would probably be to do both of these the same way and just have the search index talk up there, and then you sort of figure out, no, I need another microservice in there, need to spin that up. That's a normal thing. So you need to be able to get up and running with them fast, and at the same time, you still need them to act like the other ones with regards to stuff like logging and monitoring. You want them to be well-behaved. Other things that can sort of come into this being well-behaved could be things around security. So you might want to make certain that only the services that are allowed to talk to each other are allowed to do that. So you have certificates allowing stuff like that. Whatever you sort of decide your needs are. And this is where middleware comes into play. Because when you're doing everything over HTTP, then middleware in the sense of ASP.NET Core middleware, which we're going to look at, and in the sense of OWIN middleware, which we're going to look a little bit at as well, is a really good place to implement these things. Right. So let's sort of turn away from microservices for a bit, because this was sort of the motivation for doing these things, and then talk about what middleware is. So first of all, what any web API or HTTP-based API does really is handle HTTP requests. Wow, big surprise. So what does that kind of mean? In an ASP.NET Core sense, you're basically doing this. You have a pipeline. At the one end of the pipeline, there's the Kestrel web server. So every request comes into this guy, and sort of off the wire, and Kestrel looks at it and turns it into something that your .NET code can understand, and your .NET code is over here in the application. So Kestrel sort of sends the request in here. You do whatever application logic you need, and the response comes back. Kestrel knows how to serialize that and put it out over HTTP. That's what a web server does. Not too complicated here. Now, that pipeline can be longer than just the two bubbles I had there, and the pattern behind it is pipes and filters. So request comes in, and they get piped through a number of filters. And the way the request gets piped through is through what's called the context. So we're going to look at the context object as well a bit later in the talk. And the context holds everything regarding the HTTP request and everything regarding the HTTP response as well. And the middleware are like the filters in the pipes and filters pattern. And it looks like this. And you can sort of go on and have more complicated scenarios in there. So in this one, we just have Kestrel here at the one end, we have the application still at the other end, and then we have two pieces of middleware there. And first one, a throttling middleware. So one could imagine that we set up limits such that any customer that isn't a paying customer can only make a certain amount of requests per minute or a certain amount of requests per day or whatever. I think some of the Google APIs does stuff like that. And then sort of already at this point, if the client is above the limit, you just return a suitable status code that tells them that they're not alive to do this. And if they are, you go on. Then you might have some authentication. Middleware looks for an OAuth token and checks whether it looks valid and so on. And then you go into the application. So we're using middleware here to push some stuff out of the application. And it's sort of technical kind of stuff that you don't really want in the application code. It's not really business related as such. And what these pieces of middleware can do is they can transform the request and the response. So on the way in, they can do stuff to the request. A lot of the time, it's really just looking at the request, but you could actually sort of do stuff to it. And then on the way out, it can transform the response. And sort of as a important bit is that each piece of middleware sort of decides whether the rest of the pipeline gets to run. So not only can they transform the response, they can just sort of short circuit and say, I'm going to create the full response and be done with it. So that's what that throttling middleware might do. You're over your limit. I'm not even going to call those guys. I'm just returning here. Right. So each piece of middleware takes in this context. And then it can call the next step in the pipeline if it decides to, or it can decide not to. And the trick really is that that's a uniform interface. So at each of the arrows between the bubbles, it's the same thing flowing there. It's that context, and that means that you can that you can rearrange, and that means that you can plug more things into it. Like when we have Kestrel at one end, it doesn't know if it's talking directly to an application or if there are a bunch of middleware pieces between in there, because it's the same interface. The same goes for your middleware. You don't know if you're the last one in the pipeline, or you're somewhere in the middle, or if it's been switched around. So it's quite sort of composable in that sense. You have these small components, and you can compose them up as you want. You get that flexibility. So things you can do in the pipeline. So you can sort of open and dispose of resources in a general sense. That could be database connections. If you want to do the per request thing, you might want to consider being more precise than that, but that could be other resources that you sort of need. You can push that out of the application logic and get it into into middleware. You can do logging, and we're going to look a little bit at that. You can do authentication. You could do authorization. You might want to do that more, some of that in the application as well. But you could do authorization in the sense of, are you even allowed to interact with this service at all? You can do monitoring endpoints. Again, as I said, you don't want to do ad hoc monitoring for every of the hundreds of microservices in your system. You just want them all to sort of react the same way. So having a piece of middleware that just responds to a well-known endpoint that says, I'm alive, that's actually really valuable and really easy to code. You could sanitize inputs. You could do content negotiation. You could do cores. You can do a lot of stuff in these pieces of middleware. And the overarching theme here is that these are cross-cutting concerns in some sense or the other. They cut across the business logic. They're not really business logic, and they cut across many of our services. These are not just about one service. They're about most or all of our services. They're reusable across the services, at least as long as you want your services to behave in a uniform way, which I'd argue you do. You can separate them and test them nicely, just one of them, and be confident based on those tests, hopefully. They can be updated separately. You sort of don't have to put everything in one package, again, because the pipeline composes. And sort of along with that, you can distribute them separately. And by distribute, in this case, I mean put them into the different code bases of each of the microservices. So really what I mean is put them into a NuGet package, and you can sort of have a NuGet package with a middleware in it, or you might sort of want to put a meta package on top of that has your entire sort of standard pipeline. But then as needed, you can go in and update one of them, and you can get moving, right? So an example of sort of a platform for building these HTTP-based microservices would be building up a pipeline like this and just making it easy to get up and running. Again, because we are going to spin up new microservices quite often, so you don't want to do this again and again. Just want to do the same thing. So this is an example. You might want to put them in a different order. You might want some more, some less, some specific to your organization. But this is an example. So Kestrel in the one end. Then you might want to attach a correlation ID to every single request that comes in. The idea of the correlation ID is to identify where things come from. So at the edge of the system, you just create a new GUID. We have lots of GUIDs. So create a new one, attach it to the request, and then every time the service logs anything, it also puts that correlation ID on the log. And when it makes calls to other services, or when it creates an event, that event has the correlation ID in there, or that call to another service has that correlation ID in a header. So it follows through the entire system, and all logs has that one. That becomes really, really nice when you have problems in production. Then you go to your log store, and you can search for a correlation ID, and you can track what happened here and why was this caused. You have this problem over here. There's a correlation ID. Find out where did that come from in the system. That's really nice. You could do request logging. So every request coming in, every response coming out, what's going on here. You could maybe do that sort of on an information level logging, so you have the ability to turn it off so it's not too noisy, but you can turn it on when you need it. Performance logging, kind of the same thing. In the pipeline here, just time everything, because it's one of those things that most of the time you're not going to have to look at it, But then sometimes something is too slow, and it's really nice to actually get to know how much time did this guy spend and how much time this guy spent. So you just have it in the pipeline, and then it's easy to turn on and off. You could have the monitoring endpoints that I talked about, so that all your services respond to something like, I don't know, /monitor, and it says 200 OK if it's alive. Or you could be more advanced about it and do something more than just returning that, actually checking something more meaningful about whether it's alive or not. And you could have authentication down there. Look at, is there a valid token on this request? Are we allowed to, is there identity here? Otherwise we might not allow anything. And then at the end of that, there's the application. These things we only want to write like once, in air quotes, because we don't get things right the first time, but we don't want to write them every time we spin up a new service. Okay, so time to actually look at some code. Yes. So I have prepared a little bit here, and it really is a little bit. I have an empty web application, and it really is quite empty. This is it. This is all it does. There's really not much there. So it will just respond, hello world, to anything down here. Ooh, brilliant little service. So that really doesn't do much. But that's a nice starting point, something that doesn't do anything really. And let's see if we can run it. So it's in this folder, and I probably have to restore packages. Boom, boom, boom. Seems okay. And let's see if it can basically run. .NET run to that. So it compiled, and it seems to be running on port 5000. So let's check that. Let's go there, and ooh, hello world. And what we might the interesting bit here is not in the browser. That's never interesting. That's just for users. The interesting bits are, of course, the logs. So already out of the box here, we actually get the request logging part. So that's kind of nice. So that's already done with. And you can see that we got a request here for a GET request for localhost 5000, and you get that request, the whole pipeline finished in a certain amount of time, and you got a 200 back from that. So that just comes out of the box with ASP.NET Core. It's kind of nice. So let's look at this middleware thing. Oh. No, that one. Staying in the same file. So if we want to do something more, if we want to do some of the middleware that I talked about. So there was already something about the milliseconds out there, and that's quite good to have. That's on the very outside of the pipeline. So that's from Kestrel's perspective. How long did everything take? I think it actually makes sense to also have your own performance logging in here that only looks at when I have taken over. So how much time is spent in my code. So we're going to set that up. Also serves as an example. So in order to create a piece of middleware, we go into this app here. So that's the application builder that we get in this configure thing. And this configure thing gets called by ASP.NET Core on startup. That's how Core works, or ASP.NET Core works. And we will say use. And that means we are going to use a piece of middleware, and we just say, yes, please, give me the signature needed here. And the first argument here is a context, and the next one is a function which I'm going to call next. And that context is the HTTP context, which describes the request and response. So this is the uniform interface I talked about between each of the pieces of middleware. You get everything about the request in here, and you get everything about the response in here as well. And then the thing called next is the next bit of the pipeline. So that's the thing we can decide to call or not based on whatever we want to do. So you have flexibility here in the middleware as to what you want to do. So let's get going, and let's just get that a little bit up for everybody to see. And we can just do stuff like whatever, boom, 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 bar watch equals new stopwatch. There we go, and then we take that watch and say start, and then we call next there, boom. And then after this, we just do our performance logging here as a console write line. Right now, right line. And so I'll do my pipeline, and we'll just say that took some milliseconds, and it's going to be just watch. Whoop. Sorry. Watch dot elapsed millisecond. That's sort of fine. Okay. So, and this is sort of almost it. There are some squigglies there. I think one of them is just a semicolon. And then sort of the other one, what's going on? Let's try to have a look if I can find the mouse. Okay, what's blah, 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 can't resolve and candidates, and I don't know. Well, I do know, actually. And the problem is that we're supposed to return a task. So this whole pipeline is async. So everything is just tasks, and Kestrel at the very end of it will await the tasks that come out of the pipeline, and that's where everything will be waited for and will really execute, right? So, and moreover, if we're just calling like this and not awaiting, we're actually not measuring what we want here, because I want to do something before and after. So I have to make sure that it's actually after. So we will await here. And yes, we'll make that async. And I guess we should, I'm not going to do this every time, but I guess I should put the configure await false in there, so I don't have to come back to the same thread context. And there is still a problem. Either that or writer is just confused. Let's save. Let's see if it builds. Oh, running, stop. .NET build. Well, let's sort of see. Okay, compiled successfully. So writer is just confused with the squigglies. Yes, lovely. And we can .NET run. And it's up and running again, and it's not going to be overly surprising, I don't think. We get in here, boom, 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 and you can see, actually after the initial one, which sort of does some warm-up, our pipeline is quite fast. So it turns out saying hello world is quite fast, because 0 milliseconds. Because really what's left in our pipeline after that piece of middleware is just this guy that says context, response, write async. And that's actually the same context you see. So this is how you just write something for the output. So that's good. So but in this piece of middleware, we didn't really do anything with the request or anything. So it's sort of okay, fine, but it doesn't do much. So let's do a little bit more in here, and we do use again. We do sort of the kind of the same thing. Doom, the context, the next guy, and we are ready. So now I want to look at whether there's a correlation ID in here or not. So now we're going to use the context. and I'm going to try to find a correlation ID in there, and that's on the context dot request. So you have a strongly typed object here that that describes both request and response, as I said. So you see you have the request and you have the response down there, and then sort of you can dot into a whole bunch of other things in there. So it's an easy way to find things on the request. And I'm going to specifically look at headers, and so now I want to look for my correlation ID, whether there's already one. So that's not a standardized thing. So of course the type doesn't know about that from the get-go. So I'm just going to define my own header here, my correlation ID. And since headers can have more than one value, you get, don't you? Yeah, you get an array of values out of this. I'm just interested in the first one. I'm actually going to say first or default because I don't know if there's one there or not. And then if there's not, I'm going to create one. Quit, new quit, and to string on that, so the types match. So now if this is in a service sort of inside of my system, it should have a correlation ID already, because I want to put the correlations ID on at the surface of the system and then pass it along on every request coming through. But if we want to write this piece of middleware in a way where I can try to reuse it everywhere in my system, we'll check. If it's there, if it's not there, we'll just attach a new one. Or, well, we'll just create a new one. And then you have to do something with it. And I'm not going to go really into details with this because of time. But sort of the thing that you'd probably want to do is, first, you'd want to attach the correlation ID to a log context. To the log context. So if we are using a sort of modern logging library like Serilog, which I very much recommend, there is a concept of a logging context, and it's and you can put sort of extra metadata there. So if I put this correlation ID into that logging context, then wherever in my application code I say log.warn something is wrong, then along with that something is wrong message, my correlation ID will also be there in the log message going to my log store. So you make sure that everything inside of this this service logs the correlation ID. Now the other thing you also probably want to build, which I'm not going to build here because we're concentrating on middleware, is that you also want to make sure that the correlation ID is passed on to the next guy in the chain, to the other services coming along. So you also you want to store the correlation ID in something like an HTTP client factory. So what I've done before is, create a factory class that can create an HTTP client for me and use that HTTP client to do calls. And then you just sort of, on this level, inject the correlation ID into that factory, and then the factory sets up the client such that it has the my correlation ID header on every request and put the right correlation ID in there. The next guy in the line has the same piece of middleware. He'll file the correlation ID, put it into his log context, and you'll get them on all the logs. So it's one of those things. When you have a production issue and it has to do with something that's spread across these microservices, it just feels magical to have the correlation IDs. It's just so much easier to follow what was going on, and it's actually not that hard to code. Right. And once you have this set up, then this guy would also call next. And in this situation, we actually don't want to do anything after the next, so I don't have to await. I can just return the task that next returns. So I just pull that up. No reason to await if you don't want to do anything afterwards. Just sort of pass it on to the guy before that, and then when somebody actually needs to await, then they should await. If you don't, just return it, and it's the generated code is simpler. Right, let's save. Yes, and I'll just check the time. Good. Yeah, I guess we could sort of try to prove that both pieces of middleware actually run. Here, if we just do a write line of correlation ID, and I can't spell, that's okay. And we do correlation ID, there we go. So we're just going to log that out as well. Did I save? I save now. Stop that, rerun it, and it should compile. There we go. Do a request, and yes. So obviously it got a new correlation ID, and it'll get a new one if we do one more request. Boom, boom, boom. No big surprise, you get new GUIDs. Woo. We can create GUIDs. Right. So this is so I guess no. I think I'll create one more piece of middleware, and then I'll show you how to do it with classes instead of with these lambdas, because that's easier once you want to package them up and share them across things. So move this up a bit again, so everybody can see. And so we talked about the monitoring endpoints. So it's really the same thing, that you can just do context next, and then in this case we again want to look at the incoming request. So we just say if context.request.path, you have the path in there, and we're going to say, I guess we're going to say equals something like /monitor. So if we hit the /monitor endpoint, then we'll just do what that guy down there does. Actually, we will actually return context. Oh, not able to type apparently. No? Okay. Type.response. .write async. And you could sort of write the version of the service out here. It's again one of those things. Kind of nice to be able to get to know which versions of the services are running, and I'm sure you can imagine, instead of hard coding it, reading it from whatever config that you have, so you get a build number in here or something like that. So it's quite easy to figure out, why is the service behaving differently than I thought? Go to the monitor endpoint, see which version is running, compare that to your repository. Maybe you have like the git char outputted here as well, so you know what's running. And this is an example of short-circuiting the pipeline and deciding not to call next in some situations, and in other situations deciding to do call next. So yeah, so you continue to our hello world application down there. If it's not the monitor endpoint, if it is the monitor endpoint, then we do that thing. Okay, let's just check that it runs. I don't think shouldn't be too much surprise here. I hope. Well, running. So we can do the hello world request still, and we can go to /monitor, and we will see. Yeah, you get the version 1.0 back there, and it's the same pieces of middleware that run before that. Okay, so I think you get the picture. you can do stuff in the pipeline. Back to this guy. So I am going to cheat a little bit because I want to show you how it looks if you actually want to share this across stuff. So I'm going to check out my library branch here. Please commit or stash. That's okay. We will just get rid of everything. Git check out dash. So good. So I'm on another branch. It's mostly the same thing. Now let's see if writer got confused. Okay, writer is reloading and restoring packages and stuff. You can see that in the Solution Explorer thing. And now it is back, and we have something kind of similar to what we had before. We have the same sort of performance logging middleware there. And then we have something that looks slightly different here. So it doesn't say use, it says use middleware, and the thing it's using is monitoring endpoints middleware. So now I've separated that out to something up here in my middleware library. So that's just a standard class library, well, .NET Core class library with a project.json file there and a single CS file. Nothing complicated there. I just didn't want to do that live because it takes a few steps and it's boring. But it was just scaffolded with the .NET command line. And then in this file, this aptly named library.cs, I have my middleware. And again, it's more or less the same. Only if you do it this way, you sort of split the things. It's the same arguments, really. You have the next here, so that was the second argument when we did it as a lambda. Now you get that in through the constructor. That kind of makes sense. It's when you're constructing the pipeline that you instantiate the thing and you set up the whole pipeline, so you can, at construction time, know what the next parts are. This gets passed in, just save them off, and then in that invoke method, you get in an HTTP context, and then on each and every request, that one will get called if we set it up. And that's what that use middleware that we saw in the startup does. That's what this guy does. So it instantiates this guy, monitoring endpoint middleware with the next, and then it calls invoke. So at this point, I mean, this is just a class. This is just code. The other one was also just code, but now you separate it out and doesn't even have to look in any kind of way weird, and we still have the monitoring endpoint. And sort of as an aside here, you can get more stuff in here than just the request delegate. The request delegate is an ASP.NET Core type, which is, well, just describes the function that you can call, which is the next one. It's just a function type. But you can get more things injected here. So ASP.NET Core out of the box comes with a concept of dependency injection, and sort of its own services is already in that container, so we could depend on some of those, but we can also have our own stuff in here. So we could imagine, sort of, if we wanted to do some better monitoring endpoints, we could have sort of like an iMonitor thing here. And maybe I don't even implement that here. Maybe that's up to each of the services. We did that in one of the systems I've worked on. Define this interface and just has one method, which we call deep, and that was supposed to implement something that made sense to each and every service. So, and then that's just a different endpoint. If you hit like /monitor/deep or whatever, it calls that iMonitor.deep. And if that's successful, it says 200. If not, it gives back some other status code based on that. And then you can sort of have some of it just be standard behavior, and then you have a hook, and it's quite easy to just set up and have it be application specific. So it's nice that you can depend on other things up here, and you just get them in dependency injected. Easy enough. Right. So back to the start of CS. looks like this. Let's make sure stuff runs. Let's see. .NET run. Compiles. It's up and running. And so it's slightly different. This one, it had an underscore monitor, the code here, and it get the version, and it's all the same. So that's all nice and good. So I have 5 minutes left. It's good. So all the code we've seen so far is for ASP.NET Core. You can do similar stuff if you're not on Core but on ASP.NET. But it's sort of kind of a step more to it. You can have the concept of middleware. You just have to use OWIN. So OWIN is an open standard developed by the community. It's open web interface for .NET, and it's really awesome in many ways. This is sort of and it's really nicely put together, and really has a lot of focus on not depending on anything specific. So there's no sort of, you don't need sort of an OWIN DLL or something like that. There's no sort of common type in there. But the downside of that is that things get kind of primitive. So where we have the context.request.headers, then with OWIN, you just have a dictionary from string to object. That's the context. But the trick is there's a library that you can use if you want to, sort of your decision. And I'm just going to quickly show that. So we're going to going to check out another branch. This one, libOWIN. Go back into writer. It should, yes, reload again. And now we have one more OWIN middleware. Here it says. And we can do something similar. We have this one. So this kind of looks similar. And this works on ASP.NET Core, or it works on ASP.NET today if you use the Katana library. So if you're in a transition area, then OWIN is probably the place to look to do these kinds of things. So how this one works, more or less the same. Again, I have a constructor that takes in the next guy. Now it's not a request delegate, it's something called an app func. And the app func is this guy up here. Blah, blah, blah. You just copy this off the internet, and you're fine. And then the evoke takes in a dictionary from string to object. And that's a bit cumbersome to work with, because then you do something like look up the string. If I remember correctly, it's something like OWIN:request headers, and then that's an array of strings, so you cast the object and then you look in. And maybe I'm even remembering this wrong. The point is, it gets to work a lot with primitives. So there is a library called libOWIN, which you might want to use. It's sort of a source-only library, so you don't get a DLL from that library. You can install it as a NuGet package, and then you get a huge CS file here called libOWIN, and you don't have to look into that. What it does is it gives you an OWIN context here, and then you're sort of back to be able to saying this and this, and it looks very much like the other thing. So you can do the same thing today, and you can sort of have it across there. To set that up in ASP.NET Core, you tell ASP.NET Core that now I don't want to use your kind of middleware, I want to use OWIN. So this is a sort of a bridge between the two worlds. And then you do something like this. So again, everything is functions with OWIN. So this is a function. You call that function, and then I new up the middleware and give it the invoke method, which has the correct signature to fit into the pipeline. And then OWIN builds it up, and you are good to go. So you can do the same kind of thing. Right, 1 minute left. Back to the slides. And so as I said, and as I hope you sort of accept, it's quite flexible what you could do in middleware. They're quite componentized. They can be reused, reorganized, and since you just have these small classes that do simple things that you can easily new up from your unit tests, they're quite testable as well. So go use middleware, yay! And here's the contact information if you want to get a hold of me, and I'll be around for questions and stuff if you want. But I think time is up. And we have 1 minute for questions if there's anything before the break.
Is the code on GitHub somewhere?
It's not, but I could. Yeah, I will. Yeah, that's fine. Yeah. And I will tweet the link. Yeah. Good. Okay, thank you.